Let us see how these concepts that we have learnt helps us to solve certain questions, especially the MCQs, which are very important. The first question, Euclid's division lemma algorithm can be applied to only positive integers, only negative integers, or all integers except 0. What do we think? When we started division lemma with an example, and I remember we started with the example of boxes and pencils and erasers, real life objects. So, Euclid's division algorithm can be only applied to positive integers. Euclid's division algorithm can only be applied to positive integers. Second question, very important, directly applicable. Euclid's division lemma is directly applicable to this question, and here we can see the use of Euclid's division lemma in solving various problems. It's given if the HCF of 65 and 117 is expressible in the form of 65m minus 117. What does it mean? That the HCF of 65 and 117 is same as this. So if I write it, HCF of 65 and 117 is equal to 65m minus 117, then we need to find the value of m. Very simple. First we will find out the HCF of 65 and 117 using Euclid's division lemma. What does it state? We start with factorizing the larger number 117. If I factorize it using 65 as one of its factor, it will be 65 into 2 or into 1. Yes, if I multiply 65 by 2, I'll get a number greater than 117. So it will be 65 into 1, 65, and the remainder will be, what will be the remainder? The remainder will be 52. Next step, this 65 will again be divided by 52. Again, we cannot take it 2 times because 2 times will give me a number greater than 65, 1 time, and the remainder is 13. Next step, this 52 will again be divided by 13, and this time 13 will exactly divide 52 4 times, and the remainder is 0. Now, the divisor for which we are getting the remainder 0, that is 13. So, the HCF of 65 and 117 is 13, and it is given that this 13 is equal to 65m minus 170. We can easily find out the value of m. 13 plus 117 is equal to 65m. So, 130 rather, not 140. So, from here we see (117) plus 13 is equal to 65m. So, 130 is equal to 130 divided by 65 is equal to m. So, what would be the possible value of m? M is equal to 2. M is equal to 2. So, the correct option is m is equal to 2. Coming to the next question. If two positive integers p and q can be expressed as p is equal to A into B square and Q is equal to A cube B, then find the LCM of P and Q. Let me first write it down. P is equal to AB square. And we know to find out the LCM, we need to prime factorize them or split them into co-primes. A into B square. Similarly, Q, which is equal to A cube B, is A cube into B. And what is the rule for finding the LCM? LCM of P comma Q is equal to, we take the common bases A and their highest power. I take the common base B and its highest power. So the correct option is C. So here the fundamental theorem of arithmetic is important. Next question, the least number that is divisible by all the numbers from 1 to 10. That means we have to find out the LCM of all the numbers from 1 to 10, both inclusive. Let us first write down all the numbers from 1 to 10. Let us write it properly so that everything fits. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now let us write down all the prime factors of numbers from 1 to 10. 1 being neither composite nor prime cannot be written as prime factor. We cannot write down prime factors of 1. The prime factor of 2 is 2, itself being a prime number. 3, 4 can be expressed as 2 square. 5 has only one prime factor, 5. 6 can be written as 2 into 3. 7 can be written as 7 because there is no other prime factor for 7, itself being a prime number. This is 2 cube, this is 3 square and this is 2 into 5. Now for finding LCM, what did I tell you? That for finding LCM, we have to look for the same term, that means the common base. So the first common base is 2. We are not including 1 because 1 is not a prime number. So and any number multiplied with 1 will give me the same number, the number itself. So the first common term 2 and its highest power is 3. The second common term 3, its highest power being 2. The third common term 5, its highest power being 1 everywhere, then 7. So we get 8 into 9 into 5 into 7, which will give you 40. I multiply it in a very convenient way, 40 into 36. And the answer will be 2520. 40 into 63, not 40, it will be 40 into 63, not 36, I have written opposite. So 8 multiplied by 5 and 9 multiplied by 7. So 40 into 63 will give you 2520. So we have seen the application of Euclid's division lemma, as well as we have also seen the application of fundamental theorem of arithmetic in solving questions. The next question, another important question, 7 into 11 into 13 into 15 plus 15 is a composite number, a prime number, neither composite, neither prime, none of these. I know every composite number can be expressed as a unique product of prime factors. So, if I prove the same, it will be proved that it's a prime number. Otherwise, it's a composite number. Otherwise, it will be proved to be prime. Now, if I write 7 into 11 into 13 into 15 plus 15, there are two terms, the first term being this and the second term being this. Right? Now, from the two terms, if I take 15 common, I'll be left with 7 into 11 into 13 plus 1. Now, 15 is a composite number and 7 into 11 into 13 plus 1 is another number. That means this number has two factors apart from 1. Other than 1, the number has two factors. So, it's a composite number. That's all about the chapter real numbers, the important topics that we have learned and how it's applicable and how do we solve the questions. Thank you so much.